So we learned about mean absolute error. What about other metrics? Are we going to learn other metrics? Well, there is another metric that I want you to introduce to. It is called root mean square error, or RMSE. Okay, this is another way, this is another metric to measure the performance of a regression supervised learning model on a data set, either training data set or testing data set, but we care more about the testing data set. So let's demystify this root mean square error. We know the definition of error, We know the definition of error. The definition of error is the distance between actual values and predicted values. And predicted also is called estimated. Okay, in estimation. So it says that a squared error. So error power 2. Okay, this is squared error. And then it says mean. So divided by the number of cases. And it says that root mean square error, which means that this. And this is the formulation. So this is all the formulation. And I just wanted to show you that it's not as scary as the name. So let's see that what is the rationale behind this metric. So if we calculate error, once again, it would be 100 minus 50, it would be plus 50, 200 minus 250, minus 50, 120 minus 170, minus 50, 80 minus 30, 50, and 90 minus 90, 0. Okay, so if you recall, in mean absolute error, we use the absolute operation to remove these minus signs in order to prevent them from canceling out each other. Otherwise, this would cancel this one, this would cancel this one, when we wanted to aggregate all the errors. So another way to get rid of the minus signs is square. So squaring, it means that multiplying the value to itself or by itself. So for this one would be 200, 2,500, 2,500, 2,500, 2,500, and 0. Okay. And then now we can sum them up, but again it would be 10,000. But again we would have the problem of growing this number, so growth of this number by growth of the set of the cases, of the number of predictions. And why is it a problem? Because it shows that the performance metric is changing, while actually the performance metric is not changing, but the number of cases, the number of predictions that this model is doing is changing, is growing. So we have to make it independent from the data set's size. And how to do so? Well, easy. Divide by the number of predictions. Here, number of predictions, 1, 2, 3, 4, 5. So divided by 5, it would be 2,000. And this is the mean squared error. So the mean squared error, if you recall the unit, let's say that the unit is pound. This is pound. This is pound squared. This is pound squared divided by a number. This is pound squared. We rather to have something in pound. And this is why we do the root. So the root of 2,000 would be, I think it would be something around, let me calculate it. Something 40 something it must be. So it would be something around 44, a little bit over 44. And this is the performance of our model using RMSE. So you learn two different metrics. And the value of the performance of our model using mean square error, root mean squared error, and mean absolute error are different, as we can see. So actually our root mean square error is always greater than or equal to mean absolute error. Okay, so which one is a better metric to be used? Well, we talk about it, we answer it to somehow in the next slide.